All right, so we're dealing with solutions still. We're talking about molarity. Today we're going to discuss a look at the math involved in dilutions. Okay? So what does dilution mean? It means you add solvent to a solution of higher concentration to make a solution of lower concentration. Okay, that's what it means to dilute something. So I'll give you kind of a practical example that may be helpful to you. If where I grew up in South Georgia, when they make sweet tea, they make sweet tea. I mean, it's like it's close to being syrup. Okay.
My mom, she hates getting tea from Georgia.
Really?
She hates it.
Okay. I mean, it's sweeter than Beacon tea, folks. So, when I was growing up, nobody had unsweetened tea, but now they do. I mean, usually whenever I go to eat at some of my family lives down in South Georgia, North Florida, they'll have both. So if I want tea that's not as sweet and not as thick, but I want some sweetening in there, I'll mix the two together, and that's diluting the sugar. Yes.
Yes. Or you can put water in it.
If I want the tea part, the brown tannic acid part of it, to be less strong, then yes, I'll put water in to do that too. Yes. Before the solvent, add solvent. Add solvent to a solution of higher concentration to make a solution of lower concentration. It's really not more complex than that. But in the sciences, in chemistry in particular, we need to know exactly what the concentration is in order to do the work we need to do. Okay, so we need to know how to do the math to figure out how to get the solution concentration we want. And that's what this is about. This math is about figuring out how to get the concentration of a solution that you want if you're starting with a higher concentration solution. So here's an example. If you have plenty of a 12 molar hydrochloric acid solution, but you need 100 milliliters of a 2 molar hydrochloric acid solution. How much of the original solution do you need to dilute? So if you have 12 molar hydrochloric acid and you need 100 milliliters of 2 molar hydrochloric acid, how much of the original solution do you need to dilute? That's the question. Okay, let me give you a few tips for solving these kinds of problems. Now, this is not steps for solving it, it's tips It's prerequisite information that helps you figure out how to do this, okay? The starting amount. Now remember, we've talked about what starting amounts are a lot in here. In this class, for about 6 weeks, we've been dealing with what we call starting amounts, maybe even longer than that. Starting amount is the thing you start with and you put it over 1, right? The starting amount in this kind of a problem is always going to be the volume of the solution whose concentration you know. After we finish doing dilutions, we're going to do solution stoichiometry, and that will be also how you figure out what your starting amount is for stoichiometry, solution stoichiometry. Starting amount is the volume of the solution whose concentration you know. Okay? Tip B. You have to write molar concentrations as fractions. Such as 1.00 molar NaCl written as 1.00 moles NaCl over 1 liter of NaCl solution. Okay? Because that's what molarity is. It's moles of solute over liters of solution. Okay? And C, you need to know that concentration fractions like this can be flipped if needed. Chandler.
Chandler.
Chandler. Chandler. Chandler. Yeah. Chandler. Chandler.
Okay. I want you now to read the problem. Figure out in the problem what the starting amount is based on what I said here in A, and write the starting amount over 1 as we've been doing for 6 weeks. Read the problem, figure out what the starting amount is, put it over 1 the way we've been putting starting amounts over 1 for 6 weeks.